look at simplifying exponents. So to start off, this is a pretty difficult question. What we're going to do is we'll deal with everything that's on this top of this fraction to start. Hopefully it'll look like one term, and then it'll just look like one term divide another term. Okay, so we'll kind of disregard the bottom to start, and we'll just look at what we have on top. So what we have on top, this says multiplication. We have two brackets beside each other. Think of it like they're multiplied. So the very first thing to do is to multiply the coefficients, so the actual values there. So negative 16 times positive 5 is going to give you negative 80. Okay. So that number is done. We've kind of, think of it like we've simplified the 5 and the negative 16. Next one, we need bases to be the same. Well, we have s and s. Okay. So I know we're going to have a base of s. What it's going to be is unsure. We know by our rule that when we multiply, we add our exponents together. So we have negative 2 and negative 3. So let's kind of do that on the side. Negative 2 plus negative 3. And that's going to give us negative 5. So we now have s to the negative 5. Okay. And then that takes care of that one. And finally, t. Okay, we're going to have base t because t is for both. Same idea, but this time it's 2 plus 3, which is 5. So t to the 5. Good. So now that we've dealt with simplifying those all into one term, okay, we have negative 80, s negative 5, t5 over 4, 4s2, t negative 3. Okay, s2 negative 3. So again, very first thing we're going to do is simplify the coefficients. So negative 80 divided by 4 is going to give us negative 20. So those are now simplified. Okay. S's. The S's are both base s, so I know I'm going to have base s. But this time I'm going to have negative 5, and because it's division, we subtract. Subtract 2. Well, that's going to give me negative 7. So I have s to the negative 7. And finally, so that takes care of that, we have base t again. T, and same idea. We're going to subtract the exponents. 5, subtract negative 3, which is actually similar to addition. So if you use a calculator or whatever, you're going to end up with a value of 8 here. And I wanted that to be in red, actually. 5, negative 3, 8. So now I go to the power of 8. That's technically it. Now, I don't know. Sometimes the teacher will tell you, make sure everything is a positive exponent, which we'd have a problem here because our s is not a positive exponent. But we know we can turn a negative exponent into a positive exponent by doing this. Think of these, and I see how I put a pair of brackets. Think of them like this. If it really gets confusing, you can just isolate every single thing by putting a set of brackets around it. So let's change this. This is a fraction over 1, so now I still have negative 20. Okay. And to make that a positive, I go 1 over s, still to the power of 7, times t to the 8. Now this technically works, and they'll tell you to simplify 1 to the 7, nothing's going to change. So really the 7 only needs to be applied to the s. And if we're multiplying fractions, think of it like we're multiplying fractions. I know I'm taking a couple extra steps which you can kind of jump from here to here. I'll show you in a second. But this is what's really going on. When you multiply fractions, you do top by top by top. Well, 1 to the power of 7 is just 1. Nothing changes, not important. So really it's negative 20 times 8t. So we have negative 20 times 8t on top. And on the bottom, the 7 really only gets applied to the s, so s to the power of 7 times 1 doesn't change anything. S to the power of 7. And now every exponent is positive. So you could have kind of just done this. Anything that's negative, put it a fraction and make it positive on the bottom of the fraction. Or vice versa. If it was on the bottom and it was negative, you just bring it back to the top and make it positive. Okay. This is just what's going on in that case. And if they don't ask you to make it positive, then that's more than an acceptable answer.